everyone, welcome to Samadhan Life Science. Before I start today's topic, I have an announcement for you. So, we are launching soon a recorded course for GATE Excel Chemistry syllabus. Here, you will get lectures on full syllabus and 10 years of previous year questions solved in detail. So, if you want to just revise the chemistry syllabus or want to complete the syllabus systematically, check this course. This will be available from next month. Now to proceed with today's topic, we will discuss today stereochemistry, which is an important part of organic chemistry chapter and also scoring too. So in stereochemistry, we discuss about spatial arrangement of atoms in a molecule in 3D space. So a molecule can have two molecules can have same molecular formula but have different spatial arrangement of atoms around the central atom, and those will be stereoisomers. So for stereoisomers, we mainly have two types. First one is geometrical isomers, where cis-trans isomers are there around a double bond, and the second one is optical isomer, which I will discuss today in detail. So for optical isomerism, we need a chiral carbon. So what's chiral carbon? So if a carbon has four different type of groups around it, for example this, then this carbon is chiral carbon. So I will represent this with a star, and if I put a mirror here, then for this mirror image, so the atoms will have same connectivity with the molecule in the molecule with the central atom, but I cannot take this mirror image and superimpose on this original molecule. So these two mirror images are non-superimposable. So this molecule has a chiral carbon atom and have this mirror image with which is non-superimposable. So these two are our enantiomers. So these are optical isomerism, specifically named as enantiomers. Now in your GATE Excel exam, this type of questions is asked. So you will be given two molecules and you have to identify which type of isomers are they. So you have to first check if the connectivities are same. So in this molecule, this group is connected to this carbon which is next to nitrogen. But here next to nitrogen are different groups, and this group nitrobenzene is exactly opposite to nitrogen. So connectivities are different. So these are constitutional isomer where the connectivity is different. So option D is correct answer. But if the if the connectivity is same in the molecule, then you have to check for enantiomer, if stereoisomerism. If they are mirror images, then enantiomers, and if they are not mirror images, then they will be diastereomers. Now all the chiral molecules must not have the chiral carbon. For example, this type of molecule, this is allene. Okay. So if I replace these two and these two hydrogen with different groups, for example like this, then for this molecule, also this allene type molecules, rotation along this axis is forbidden because of this back-to-back double bonds. So this is a chiral molecule, though this molecule does not have any specific chiral carbon because of this axial chirality. Okay. Now which molecules are not chiral? So if the molecule has CH2 or CH3, then the molecule will always have a plane of symmetry. Or if the in molecule like this, if the carbon has two same group. Okay. Now the third one is if the molecule has a plane of symmetry. For example, if I take a cyclobutane like this and two methyl groups are attached to this cyclobutane, then one plane of symmetry will be through this. Okay, and this molecule will be achiral, though these two carbons are chiral molecule, but this molecule will be still achiral. Now let's move on to the nomenclature of stereoisomers. So let's take a chiral carbon first. So bromine, chlorine, CH3, and in the back hydrogen. So this means CH3 methyl group is towards me and hydrogen is in the back. So to name it by the configuration, first you have to identify the attached groups by their atomic number. So the heaviest one is bromine. So I will put 1, 2, 3, 4 by their atomic number. Okay, so if this 1, 2, 3, 4 is in anti-clockwise order, then this will be S configuration. And then let's move on to the its mirror image. It's enantiomer. So it will be bromine, carbon, then here hydrogen, methyl, chlorine. So 1, 2, 3 and 4. So this is and clockwise. So this will be R. So if the 1, 2, 3, 4 is in anti-clockwise, then S. If in clockwise, then R. Now one important thing to notice here is hydrogen is in the back. So if the hydrogen is in the back, you have to calculate it like that. But if hydrogen is not in the back, if suppose hydrogen is in the front, then just reverse the configuration. If you are getting an S, then the correct answer will be R. Just reverse the configuration. And if the hydrogen is in the plane like here or here, then swap the hydrogen with the back group and then reverse the configuration. I hope you understand. Let's take the last example for today. This is also a PYQ. So the correct statement regarding the given molecules. So the options are based on chirality. So let's check one by one. So for this first molecule, we have a plane of symmetry through this. So this will be a chiral. Why plane of symmetry? Because if I put a mirror here, this and this will be, this side and this side will be mirror images. Same for the second molecule, a chiral. For the third molecule, here I have a chiral center and second chiral center, but here is a plane of symmetry. So this is also a chiral. So this type of molecules are called meso compound. For example, if I take a molecule like here, COOH and then COOH, OH. So this is an chiral center, this is also an chiral center, but here is a plane of symmetry. So overall the molecule will be achiral, and this type of compounds are called meso compounds. So let's check the fourth option. So here is one chiral center, second chiral center, and this does not have any plane of symmetry. So this will be only chiral molecule among these four. So let's check the option. Both 1 and 2 are achiral molecules, right? And 4 is a chiral molecule, right? So I hope this clears for you the concept of stereochemistry. Thank you for watching. See you in the next video. Bye bye.